And welcome back, everybody, to another lesson on rates. This time calculating unit rates when using complex fractions. If you're asking yourself what is complex fraction, that would be coming up. Go ahead and pause, take a look at assignment number 1, take a look at your answers from the front page. Come on back when you're ready. And to the back page, come on back when you're ready as well. Bring your questions if you have any, and here we go. Complex fractions, we call them like the Big Mac of fractions because Big Mac, 2 patties of hamburgers, the numerator and denominator or both, are fractions. Now, it's kind of complex. It can be simplified, though. After all, who wants a fraction inside of a fraction? 1/4 of 1/3, 1/4 split it up into thirds is actually 3/4. The question is, how do you do it? So we take a look. Now, I want you to think about a fraction as nothing more than a division problem. Right? So let's think about this problem. Josiah can jog 1 1/3 miles in 1/4 of an hour. Find his average speed in miles per hour. Now, first step, write the ratio. Notice that I always write the units in before I write the numbers. So once I write miles per hour, then it's a little easier to make sure I don't mix up the fractions. Now, second step, what does a fraction bar mean? It means divide. So we're going to go ahead. What's this hint here? Easy as pie, flip the second and multiply. Nice little rhyme from the previous teacher. Meanwhile, the rest of us realize first things first, change this to improper. Next, there is no division in the dividing of fractions. We're going to multiply by the multiplicative inverse. Multiplicative inverse of 1/4 is 4 wholes. Now we go ahead, simply multiply, nothing reduces here, and we quickly find out it is going to be about 5 1/3 miles per hour. So that's that, folks. That's complex fractions. If you got some nastiness, if you got a fraction inside of a fraction, even both numerator and denominator are fractions, simply change it into a division problem, divide out, and simplify. In this case, Josiah, his average speed was 5 1/3 miles per hour. And now that you have per hour, you have a unit rate. So let's do a couple more examples. Once again, I'm going to go ahead and switch this. 14 divided by 7/9, and I'm going to go ahead and make 14 as in 14 wholes. Now we remember that there is no division in the dividing of fractions. We multiply by the multiplicative inverse, which means 9/7 will change to 7/9 will change to 9/7. Many of you will multiply first. I choose to reduce first. 7 divided by 7 and 14 divided by 7 reduces quite nicely, leaving us with 18/1, or in other words, 18 wholes. That was when only the denominator was a fraction. We take a look at number 2, where only the numerator is a fraction. Nevertheless, we can rewrite this as 2/3 divided by 7, or maybe we should write 7 wholes. And remembering that we flip the second and multiply, 2/3 multiplied by the multiplicative inverse, nothing cross reduces. We end up with 2/21. 2/21 of a mile per hour. Yes, but Mr. Callan, what happens if they both are fractions? No worries. Remembering, please, that fraction bar also means division. Now, just be careful, because some of you are going to be very tempted to say, hey, the 3's cancel, the 4 and the... No. The alarm bell should be going off right away, because we are still in division form. You cannot cross reduce yet. Change to the multiplicative inverse, then check. Now, in this particular case, there is no cross-reducing available, and we end up with a simplified fraction of 8/9. On to example number 4, 6/7 divided by 1/5. Make sure you don't flip the wrong fraction. We're going to multiply 6/7 by the multiplicative inverse, which is 5 wholes. Nothing cross reduces. We end up with 30/7, which we can change to 4 wholes and 2/7. 4 2/7 pounds per bag of rice, or whatever the case might be. Now let's do some real world problems. Patrick drove 220 miles to his grandmother's house. The trip took him 4 2/5 hours. Notice when I circle numbers and their labels. Question: what is average speed? And while you can stop there, I will choose to also box in miles per hour. So writing down miles per hour helps me to place the numbers in the correct order. 220 is the miles, 4 2/5 is the hours. Now we can go ahead and say, all right, so essentially what this means is 220 divided by 4 2/5. We're going to go ahead and rewrite 220 as an improper fraction. We're going to go ahead and write 4 2/5 as an improper fraction. And now we say, no, don't try to cross-reduce yet. We have to change it to a multiplication problem. Multiplicative inverse of 22/5 is 5/22. Aha! Here is some lovely cross-reducing. 22 goes into each of those numbers. And we'll go ahead and say 10 times 5 and 1 times 1, which can be rewritten as 50 miles per hour. And we've taken that ugly complex fraction, we've turned it into something that makes sense. On Word example 6, Monica reads 7 1/2 pages of a mystery book. Notice I don't really care what kind of book it is. 9 minutes is the time that it took. What is her average reading rate? Aha, pages per minute. Why is that so important? Because now when we write it, we make sure to write in pages per minute. Now go back and place your numbers. 7 1/2 is the number of pages. 9 is the number of minutes. So we can rewrite this as 7 1/2 divided by 9. Naturally, we would want to change each of those to improper. 9 is wholes, 7 1/2 is halves. We'll change that to 15 halves. Multiplicative inverse, 3 goes into both 9 and 3 goes into 5. 15 divided by 3 is 5. 9 divided by 3 is 3. 5 times 1 and 2 times 3, and basically what that means is 5/6 of a page each and every minute. Notice it's not pages, it's not plural. But that gave us a unit rate. Notice I'm not trying to say 5 pages for every 6 minutes. While that is accurate, a unit rate is when we have one and only one in the denominator per minute, dollars per hour singular, miles per gallon singular. So we want to say not 5 pages every 6 minutes, which is good, but it's not great. We want to say 5/6 of a page each and every minute. Let's go with example 7. Page mows 1/4 of an acre in 1/6 of an acre in 1/4 of an hour. How many acres does Page mow per hour? That's the question. How many acres mow per hour? 1/6 of an acre, 1/4 of an hour. Now the first thing I do is I check the per hour, means hours go down below, acres will go up top. And that helps me place the numbers appropriately. 1/6 of an acre in 1/4 of an hour. Go ahead and rewrite that as a division problem, numerator divided by denominator, and then we will switch it to multiplying by the multiplicative inverse. Some of you prefer to reduce second. I prefer to reduce first. 4 divided by 2 and 6 divided by 2 equals 2, 3. Now again, we're not trying to say 2 acres every 3 hours. While that is accurate, we're trying to say 2/3 of an acre for every 1 hour. Make that a unit rate. Let's give it one more example and then head to your homework. 2 cars are being filled with gas. Gas enters the first car at a rate of 2/3. Okay, hold on. I'm going to use this green. First car, 2/3 of a gallon per 1/4 of a minute. Meanwhile, second car, 3/5 of a gallon per 1/6 of a minute. And of course, the question, which is being filled faster? So let's go ahead and compare. I'm going to write car 1. And if we're looking at gallons per minute, I'm going to go ahead and write the units first. 2/3 of a gallon, 1/4 of a minute. Now while we're at it, let's set up car 2. Again, in gallons per minute, and if we can go ahead, write in 3/5 of a gallon in 1/6 of a minute. Now, ladies and gents, I'm going to very quickly go through this. I'm going to try not to say anything. Let's see if I can keep my mouth shut and just let the numbers and the computation speak for itself. Here we go. And the next one. So to answer this question, car 2 is filled at a faster rate. Very difficult to compare. Little disappearing ink here. Let's focus on this part. It is really hard to look at those and just say, I can tell immediately if car 1 or car 2 is faster. On the other hand, as soon as you get here, you say, come on, Mr. Callan, 3 3/5 is a lot faster than 2 2/3 gallons per minute. You get 1 minute to fill up each car. The blue is going to fill up more faster. Faster rate, at least. All right, ladies and gents, assignment number 2 is going to be happening for homework for today. Many of you received a packet either yesterday on Monday or today, Tuesday. Others of you are going to be doing this virtual only students, doing it on Kami Online. That's all I got. Have a nice day. Let's grow.